Okay, so I want to show a little bit of what I've been creating for the last few weeks in the context of this new paper that came out just at the beginning of the year, which actually inspired a lot of features that I have recently implemented in this system. And so yeah, so I mean the paper, I guess maybe I'll talk about the paper, a little bit about the paper first. It is titled A Core Calculus for Documents, or Lambda the Ultimate Document. These are the authors. And what they try to do here is they analyze a lot of document creation systems, let's say, or document languages as they call them sometimes in this paper, and they try to make sense of them in a systematic way. So they are trying to develop a formal framework to describe and design these sorts of systems, because I suppose there is no formal, unlike in proper programming languages where we have the lambda calculus. That's why I suppose the subtitle. I mean, the subtitle is a reference to a series of papers on scheme, I guess. But the underlying reference, like still more hidden, is the lambda calculus, which is a mathematical model that describes that is used to describe and analyze programming languages and also design. So the authors of this paper are trying to work out, I suppose, something in this way to describe those document creation systems. And we have Markdoc, Markdown. I guess Markdown is just a language, and it is very much featured in a lot of these systems. But the systems do a lot of things besides just converting Markdown to HTML or whatever other format they may do. So this is like so this analyzes both those languages at the level of syntax and the basic functionality of creating a tree, a sensible syntax tree from a domain-specific language, but also systems that are placed around these languages, which can also have functionalities like reactivity or other things, like reference, support for references or whatever. This is actually analyzed here in detail as well. So yeah, and what this paper does to kind of show that such formal analysis is justified and that we could use a calculus, we could use a system for analyzing these document formats. So what this paper does is it shows the bugs in various languages and systems for creating documents. bugs or just let's say unexpected behavior or quirky behavior because of the way they are designed. And also this paper tries to classify these systems by the level of sophistication, let's say, or what they allow a document author to do. So there's this table that introduces a taxonomy of document languages, and it's ordered from the least sophisticated to the most sophisticated. The least sophisticated being just string literals, and the most sophisticated is like it's called a template program in the domain of articles, I suppose the full qualified name of this would be. So this is an example of such system is, for example, Svelte. I'm not sure if this is the correct pronunciation, or Typed. It's a new, I don't know, probably, I don't know how well known is it, but yeah. But this is actually an example of this system. So we can define variables with a programming language like syntax, and then we can refer to those variables in a markdown like syntax, and so we can interleave these things and build up our document, our article. Let's say that's basically a syntax tree as opposed to a string. We can build it up dynamically within the language. So, and basically the system I am developing here is on this level. So it has features that allow this sort of functionality, and also some more things which this paper also describes as how do they call it? Let me check. Yeah, extensions, I suppose, maybe. Yeah, so references. They treat reference support as extensions, and reforestation, which is things like paragraph inference. So, for example, in Markdown, you just introduce a paragraph by separating it from other things, other text, by double new lines. And this is also how a feature that I have implemented in this system, which I codenamed Znadoc. Yeah, naming is hard, but yeah. So the reforestation is, for example, just inferring paragraphs by analyzing the text of the document, and this is what the authors consider that's how they define this. They first define the document calculus, which doesn't include these features like references or this reforestation, and then they add on to this calculus these extensions. And another major, I would say, feature in the context of this paper extension is reactivity, which is basically being able to dynamically update and interact with the document that is generated by the document system. Okay, so for example, React is probably the most well-known system for achieving reactivity, but also there's one thing that's mentioned here is Elm, a reactive programming language, which is purely functional. It's pretty nice, definitely pretty nice to use as an example in paper like this. And a formal, purely functional languages lend themselves very well to formal analysis. So that is this. And let's see. Go back to the beginning. And yeah, so we have examples of different systems and different weird behaviors in those systems. In PHP, we have a problem that stems from PHP treating the document basically. The underlying model of PHP is just maintains a global mutable buffer and appends, pastes, splices text into this buffer. But it's a very limited system, because, for example, if you want to generate an HTML list and want to put a length of this list in an attribute of this list, and also put items of this list inside the body with the same function, it's not really possible to do that. And in the system I'm developing, this is Znadoc system, and this is straightforward. It's just so we have you can include a JavaScript, just straight up JavaScript, which can be interleaved with the syntax. The JDAML format, or the JDAML syntax, which is what this whole thing is based on, which is also something I've developed recently. And it is very much like JSX, except in my opinion much more pleasant, and definitely more concise and smoother to type syntax. So, for example, here we have a JavaScript function which maps a list of elements into a bunch of list items, just HTML elements that represent list items. We could, if we had JSX, we could write the same thing as this, basically, right? So this is a lot like JSX. And then we have another function, same as in PHP here, which returns the entire list, and it sets an attribute to the list length. So in this syntax we can just introduce an expression, a JavaScript expression, by putting an equal sign after the opening bracket. It's a very much like in Excel, like if you have those cells in a spreadsheet and you want to put some expression to evaluate, you put an equal sign in the front, right? So this is very much, the syntax is very much like this, which I kind of like. So in JSX this would look like this. Actually, this things with the dot in front of them are attributes. So we would have this like this, an attribute, and then we have this thing, and then this. So this is the same equivalent expression, let's say. So here we have only one type of brackets. JSX has those angle brackets and also those curly brackets to like splice in, substitute some JavaScript expressions, and we only have square brackets here, and if we want to splice something, we just use the equal sign. And there are no closing tags, which is pretty nice. And all the characters, or most of the characters that you most often use are selected, so that you don't have to press Shift to enter them, which really makes this pretty smooth to work with manually. It's much more pleasant when you get used to it than React.